Hi National 5, sorry about that, my phone cut off because I ran out of space. So, where were we? So the shared pair of electrons that holds the non-metal atoms together, that's called your covalent bond, okay? And when I do a wee diagram, I'm going to do a wee diagram on the next page, it should hopefully start to make more sense, okay? So, let's start. So what we have, if we draw our atom out, okay, and what we have is we have our electron here, so X just equals, oh sorry, maybe put that down here, so X equals electron, okay, and we've done that before when we did target diagrams, so let's just say we've got a wee X here, and you should know the centre of an atom, yeah, everyone should know this, is the nucleus. Okay, now in the nucleus we have protons and neutrons. Okay, protons are positive, yeah, PP, positive proton, and neutrons are neutral. So overall, because the neutrons are neutral, they don't count, the protons are positive, overall the nucleus is actually positive, okay? And we show that just by putting a positive, yeah? Now what happens is when that's one non-metal atom, when non-metal atoms bond together, they share the electrons, and what happens is you get an overlap, okay? And again, you have your nucleus because it's another atom, so you've got one nucleus there, and you've got one nucleus there, and you'll get another electron from that atom. Okay? Now, what we have are two non-metal atoms bonding together by sharing outer electrons. Okay, so the X belongs to that atom, the O electron belongs to that atom. Okay, so X is electron, O is also electron. Now what happens, you should know, electrons, let's make a wee note here actually, okay, electrons are negative, okay, so if we've got a negative charge and a positive charge, what we get is we get an attraction, okay, opposites attract, positive attracts negative, negative attracts positive, okay. And it's this attraction, oh sorry, you can't actually see that if I just bring that down, so we've got an attraction, that is your covalent bond, okay. So let's make a note on what a covalent bond is. So the covalent bond is the force of attraction of the two positively charged nuclei. That is just plural for if you've got more than one nucleus, it's nuclei, okay? So the two positively charged nuclei for the shared pair of negatively charged electrons. Okay, And you need to know that covalent bond is all about that sharing of electrons. It's all about that attraction between the positive nuclei and the shared negatively charged pair of electrons. Okay, I'll just move that along so you can see it. Now, what we'll do is, like what we did with metals, we're going to do properties of covalent elements and compounds. Okay? So, we'll start with melting and boiling point, like what we did with metals. So, make a wee note here, covalent elements, covalent elements and compounds do not conduct electricity. Yeah, and we can put in brackets the reason that they don't conduct electricity is because they have no delocalized electrons. Okay, metals can conduct because they've got delocalized electrons. Non-metals, they don't have delocalized electrons, so they can't conduct electricity. And same with compounds. Okay, now the exception, okay, there is one non-metal element that conducts electricity, and we'll talk about that. So the exception is carbon in the form of graphite. Okay, so graphite, the sort of substance that your pencils are made, your pencils are made from, that there does conduct electricity. So the exception is carbon in the form of graphite. This conducts as it contains delocalized electrons. It's that simple. Okay, if they contain delocalized electrons, they conduct. If they don't conduct. Okay, so non-metal elements and compounds, none of them conduct except from carbon in the form of graphite. And you need to know that because that's a very common sort of past paper question. So melting and boiling points. The next one we're going to do is conductivity. Oh, sorry, I've mixed this up. Can we score out the melting and boiling points at the top here, and we'll put conductivity. Okay, and then the next one we'll do melting and boiling points. Sorry, that's my fault. So yeah, covalent elements and compounds don't conduct electricity apart from carbon in the form of graphite. Now, melting and boiling points, I'm only going to give you the note. We'll come back onto it when we start looking at structures and stuff like that. But basically, covalent molecules have low melting and boiling points, okay, and something that we call covalent networks have high melting and boiling points. Now don't worry about these covalent molecules, covalent networks just now. We'll come back onto that in a sort of future lesson, okay? Now the next thing that I want to do, if I just move this forward, is we are going to do Lewis diagrams. Now you don't know what this is. Well, the 4th and 5th years might, because we did it last year. But we're going to go into something called Lewis diagrams. Now I'm not going to go into great detail, I'm going to introduce it and then I'm going to stop there for today. So Lewis diagrams, let's go through this. So what I want you to do is think back to atomic theory. Okay? So if we go for lithium, in fact, let's make another wee note. So in the first shell, can you remember how many electrons that can hold? It can hold 2 electrons. In the second shell, can you remember how many electrons? And can you remember how many electrons there are maximum in the third shell? Okay, so we've got 2 electrons in the first shell, we can get 8 electrons in the second, and we can get 8 electrons in the third. So if we look at lithium, okay, now lithium, if you looked at your periodic table, has 3 electrons. So what we would do, and we did this at the time, is you write your lithium, that's your lithium nucleus, and then you do your first shell, okay, and in your first shell you can fit 2 electrons. We've got 3 electrons, so we put 1 north and we put 1 south. Okay, so the wee X's represent your electrons. Now, because the first shell's full, we draw a second shell and we can put that north. Okay, now if we go for, let's go for nitrogen. Nitrogen, if you look at your periodic table, has 7 electrons. So sorry, lithium has an electron arrangement 2 in the first shell, 1 in the second shell, 2, 1. Okay, nitrogen has an electron arrangement 2, 5. Yeah, 2 go in the first shell and then 5 left over to go into the second shell. So if we do the same for nitrogen as we did lithium, so top and bottom, north and south, and then we draw our second energy level and we go round in our compass, so we go north, east, south, west. And can you remember, we've got 1 more electron, okay, we've only used 4 but we've got 5. Can you remember what we do? We pair up, okay, and it's important when we're pairing up that these 2 are practically touching each other, they're right next to each other. Okay. Now, and again you pair up, so 5, let's say, we'll do 1 more actually, let's go for neon. Okay, neon has 10